Josh, how we solve for R if we have 1 plus R is 105? Or 1.05?
Wait. Oh, then you sorry, I'm confused with what that says. 1 plus R.
Yeah, it says 1 plus R. How do we solve for R?
And you have to is that
Yeah, Caleb's trying to help. He said get rid of the 1. How would we get the 1 to the other side? Good. So if we subtract 1 on this side, then all those people that said subtract 1 from both sides, you're totally right. You end up with R is equal to 0.05. We're almost done. Guys, what was the last direction you should have in your paper? What was the last direction?
5. Equal 5.
Caleb. The last thing was to plug in when t equals 5. So we go ahead and say, okay, after 5 units of time, after 5 units of time have passed, Josh, can you come back to your seat over here?
Oh, I'm still sitting over there?
Yeah, sorry, bud.
Here's yours.
Now, can anybody help me out? How do you do this in your calculator?
Okay, do 1, 0, 5.
Aiden, what'd you do?
I wrote this. No, I don't. I multiplied 1.05 5 times by 12.
Okay, that's one way.
And
You
then I
could,
multiplied it by 12.
okay. So one way is you could do 1.05 times itself 5 times, and then you could go ahead and multiply by 12. I'm just going to do a dot, dot, dot. Is that okay? You get the idea, do it 5 times. Then times 12. Some of you guys said, hey, there's an exponent button. Can you guys help us out? What does that exponent button look like?
X, Y.
Okay. So you could go ahead and do just 12 times, but you would have to do 1.05 to the 5. So let's go ahead and check this out real fast. For this piece right here, you would use that X to the Y button. And I think, don't you type the X first? So you're going to type the 1.05, you're going to hit the X to the Y, and then hit a 5. Some of you might want to play with that. Hey, how could you play around to make sure that you know how to use this button? What's something that you should know?
Oh, 1.
Yeah, you could do like 1 squared or 1 cubed. Couldn't you also do, Caleb, I'm going to have you move right here. Dylan's just trying to make it, and I don't think you're helping too much. But could you do something like 5 squared or 7 squared and check that you know how to use this button, guys?
Good, that's a lot.
I know, but just to check. All right, now Josh, you also had some questions on the other parts. Let's go ahead and go scroll and look over here at. Help me out. Which ones were? Oh, number 6. Oh, number 6. Okay. Let's go ahead and steal him real fast.
What?
It is going to be loud. Not quite yet. All right, now Johnny's going to be loud. There you go.
Oh, Dylan. That was so fake.
It wasn't big.
That was so
really
fake.
scary.
Why'd you say shut up?
All right, we're good. All right, Jade. What do you see in number 6? Who's A?
10.
Good. Who's R?
1.4.
No. Close. This one's A. It's how much more than 4 is. So, guys, how do I write 0.4 as a percent?
40%.
40%, because I move it over 2 places, right?
Yeah.
So we would steal that R from the 1 plus R spot, and we get our 40%. And then you're going to plug in 5, okay?
Oh, so it's not 1.4?
Mm-mm.
Okay, that's right.
The R is just the amount over. We'll look at that again today. All right, sorry, Josh. You wanted those ones on the second page.
Yes!
Which ones were they?
It was 20, 21, and 23.
Okay, we didn't like those ones.
Josh! What do you want?
All right, 20, 21, and 22. Hey, these are kind of similar, though, yeah? Haley.
I don't understand why I'm 21 and 25.
Okay. No, it's a good question. I think these got a little bit harder, the decay ones. Do you guys notice that all these were decay?
Yes, I know how to do it.
Alright, I'm gonna have you help us out. Sorry, Johnny. My bad. I didn't want you.
Johnny, it's not even loud. You know what's loud? This is Superman.
That's why you just don't go on that right. Okay, so.
No, like when you're on the right, it's not loud.
Oh,
No,
yeah.
thank you. Not right.
Alright, Aiden, help me out. Number 20, who's your A?
8.
A is 8.
Uh-huh.
So,
Who's your R?
my R.
Good, because 0.15 would be 15%. And then hold on, who are we plugging in this time, everybody? 3. We've already talked about plugging in, Alan. We've already talked about plugging in 3, right? So what got harder? Haley, here we go, right? Number 21. What got harder in number 21? Help us out. Who's A? Everybody. Okay, A is 240. R, okay, here's a struggle. We have to use this, but if it's decay, which means it's getting smaller,
Do 1 minus.
Is this?
exactly. We have to see this as 1 minus R is decay. So we set 1 minus R equal to 0.75. Now question, how do we solve for R? We can subtract 1. We can subtract 1. Now that'd be 1.00, right? If that helps. We have to subtract the 1 so that 1 minus 1 cancels. Now hold on. Who's still with the R? Okay. Yeah, we're gonna have to switch the sign in just a second. Now, guys, think about money. This would be 75 cents minus $1. You're in the hole 25 cents. And then you can multiply or divide both sides by a negative. Okay. What happens when we multiply or divide by a negative? The signs. Yeah, all switch. So now does it make sense why R is 0.25? Or hey, if you're doing percents, what would you say?
25%.
Does that make sense?
25.
Kaylee, is that better?
Yeah.
So that means
Josh, does that make sense?
yes.
So then we have our A is 240, we have our R as 0.25 or 25%, and then one more time, you just need to plug in 3 using a calculator. Is that cool?
Do we know what the answer is?
Oh, for T equals 3, can I show it to you real quick? Hold on, we gotta get it up. There we go. So for number 21, it was 240, 25%, and 101.3.
Wait, keep going.
You see it right here?
Real quick.
Jay, go ahead.
I know, right? But I didn't do that.
Oh, what'd you do? Did you kind of like mentally do it and say, hey, that's less than 1 by 25? That's totally fine. That's good mental math. It just takes some time for other people to develop that. Does that make sense?
I'm not.
So I did it right, but I didn't do it
You
right.
did it right without having to show work.
You're smart.
Just if this was something like 0.73, could you still do mental math? That'd be the question.
Okay.
You might have to do like 1 minus on a calculator or off to the side. Griffin, go ahead then. Oh, you want to do one more? Yeah. So number 22.
You still have 23.
Okay. Number 22, A is 475, right? Rob, can you help me out?
Yeah.
Is 22, is this decay or growth if it's 0.5 to the T?
It's real.
Oh, I wish, bud. Can someone else help out? Why is it decay?
Oh, because.
It's lower than 1. Do you see what I mean? So since it's below 1, it's going to be cutting it down, cutting it down, cutting it down. Okay?
Yep.
Now, if it's decay, we're still going to use the exact same 1 minus R trick. We're going to be setting it equal to 0.5. Okay, we're going to be setting it equal to 0.5. Now, guys, can't we use the same steps as over here?
Yes.
So can't we subtract 1 from both sides?
Yes.
Now remember, this is like 1.00, think money. 50 cents minus $1, what do we got?
50.
We got 50 cents, but we're in the hole, aren't we? It'd be negative, because the dollar's bigger, right? So 50 cents minus $1 is negative.
Oh, I was
50
getting thrown
cents.
off with where the numbers were.
Yeah, it would be a little easier, just to help us out. Wouldn't it be a little easier if we lined it up? Would that make a little more sense?
Yes.
So we could go ahead and have the decimal be like what we're used to, with
Oh,
the 5
much
right
better.
here. And then we can subtract them. I multiplied both sides by a negative, so R is equal to 50. 0.50, which is the same thing as what percent, everybody?
50.
Yeah, we got this. And then Griffin, you just plug in 3.
Okay.
Then what do we do with 475?
Oh, he's your A. Let me go ahead and pull it back up. So 475, oh, it's kind of low down here. 475 is A. R is your 50%. And after you plug in 3 in your calculator, you do 475 times and then 0.5 to the third.
I'm so dumb.
And you would get your 59.
Jay,
I am so
Is
dumb.
that
we
okay?
all have things wrong.
I put 4.75. That's why I got it
Oh,
wrong.
yeah, that would totally mess you up.
I'm dumb.
So you had the right idea.
I'm
You had the
dumb.
right idea. You guys wanted 23, right, Johnny?
No.
One more loud one. We're okay at 23? Can we just peek at it real fast?
Yes.
You guys see that A is 700?
Yes.
How would you figure out what this rate is?
0.005.
Yeah, you would do 1 minus, or even better, minus 1, flip the sign.
Wait, why would it be 005?
Ah, Because if you can I line it up real quick, let me show you right here on the screen.
Isn't it 995?
You would do 1.005. No. We had to do 1. What am I doing? I was having too much fun with the 5. 1.000. You guys remember how to do subtraction, right?
Yeah.
0 minus 5 doesn't work, so we think of it as a 10 and we carry 1. True? So 10 minus 5 is 5. We're going to take this one down to 9. And then we need to take this one, that's a 10, but then we take him down to 9.
Oh.
And take that one away. 9 minus 9, 9 minus 9. We have 2 decimal placeholders. Let's not throw anyone or anything decimal or anyone. 0.005. Is that good? With that, kiddos, that is the homework. Make sure your heading is on it. I don't want to take off any silly points, yeah? Let's make sure we have 100%.
Wait, keep it on there for a second.
Okay, couple seconds.
Heading, make sure you have the heading.
If you're ready, pass it on back. And let's go ahead and open up our notes.
What number is
This is homework number 11. Oh, my homework didn't get written up. This is homework number 11 that you're turning in to me right now. Before we start class today, let me get the homework that is due tomorrow so you guys take a picture. I forgot to write it in the back corner. Sorry. Let's go get rid of this. Alright, if you guys want a picture for tonight's homework, go ahead and grab out your phones really fast and then you can put them away. If you want a picture, tonight's homework due tomorrow.
I wasn't able to get to it. So I'm pretty
Okay. It's probably just
You
you
should
should do outreach.
Me too, Rob.
Alright, any more homework's coming?
Whoa!
Calling for him once, calling for him twice, and alright.
Bro,
Oh, wait.
you did it once, you did it
Wait,
again.
do it.
We didn't laugh.
Is this
I
tonight's
think
homework?
they wrote number 11 instead of 12. Oh wait, never mind.
Yeah, you're okay, you're okay, you're okay. Thanks for checking that.
Keep going out. Yeah, I know.
Alright, cool kids. Do you have your picture? Notes open. Let's go.
Bam!
Notes open, let's go.
Boom
Couple
shakalaka.
more seconds to get the picture, writing it down.
6.4 continues.
Yeah, 6.4 continue.
7.1.
Now we're gonna go look at our calendar really fast, alright? Yeah, we're still at 6.4. Thanks for checking.
Good.
You need to go back. I'll go back and show it one more time. Hold on. Okay, class calendar. You guys need to check this out because it's kind of important. I think right now this is us, right? Algebra 1.
Are we still in this?
Yes, we
Oh
are.
my goodness.
Look today up at the board. In class, finish. Josh, it's okay. Look. Finish 6.4. We had homework 11 due. Tomorrow, I need to refresh this because our homework is missing. Hold on, it's coming. Tomorrow, wait a minute. Did you guys just see a review?
I saw a review.
Aren't we about halfway through chapter 6? Not quiz tomorrow, quiz on Wednesday. So check it out. Homework 12 due tomorrow. Chapter 6 review tomorrow. We're going to use the in-book, and then maybe if you guys are good and quiet, maybe Kahoot. But you got to get some review work done first.
Look, we have a bio test on Wednesday.
Quiz.
Wednesday and this quiz.
Oh, number 12.
This is a test, bro, not a quiz. No, she said quiz on Wednesday.
And then quiz on Wednesday, which remember, there's almost always a mid-chapter quiz with Coach Pratt and with myself. So, at 6:04, we are stopping and we are studying, we are reviewing, and then we are having our quiz on Wednesday. Now, guys, you are going to want to bring a scientific calculator for Wednesday because remember this last section, there were the weird decimals. You're going to want to bring a calculator, okay? So if you don't have one, remember, I don't have enough for everybody. You need to plan ahead. I'll remind you tomorrow. And then you're also going to be turning in notes on Wednesday as well. So make sure, hopefully, they're just in your notebook. It'll be super
Make
easy
sure they're all.
just to get them all, to turn them all in. Make sure your name is on the front page. We'll talk about it more tomorrow, okay?
They were in my other building.
Okay. Take a picture. All right, here we go. Does this look familiar, kiddos?
Sure does.
Ah,
We're just
it
doing.
should kind of, right? Remember, growth says there's a percentage that. All right, here we go. Notes open. We're continuing. This is not a new section. Quick remember, exponential growth. It's growing by something greater than 1. Hence, we're adding a percentage. Decay. Okay, you guys got it? Okay, sorry, step down. Hang in there. Decay, we're decreasing by some percentage lower than 1. Let's try that. Stop dropping stuff. Okay. Now, we're going to start off right away with examples. So I want you guys to get ready, but real quick. Do you see these equations in your notes?
Yes.
Okay, I want you to, if you haven't already, star them, or if you have a highlighter, highlight them. They're very important equations for section 6.4, yeah? Very important equations for 6.4, but then we're going to do some examples, take a little bit more notes, and then be done. We're still on 6.4. Thank you for checking. We're still on 6.4. Yeah, Josh. Started off really tired this morning, but I bet you guys did too. It's a Monday, huh? You get home till
I thought it was Friday.
That's rough. Well, that's a bummer, Rob. It's like the worst way to start a Monday is thinking it's Friday. All right, let's go check out some examples. Okay, you guys had 1 or 2 like this in homework. I think you had 1 or 2.
Yeah.
Oh, go back like that? It's okay. Go ahead and take it. You can still need to write it. Tyler's still getting it. I know. Tyler's still getting it. All right. You can. Here we go. Okay. I want you guys to read the 2 statements. Actually, you know what? I want you to write the 2 statements. Okay. Word for word. And as you're writing it, I want you to ask yourself growth or decay, and then look at the 2 equations that we just reviewed. Yes, please. You could shorten it a little bit, like salary of 35,000 increases by.
No, I'm saying write the instructions.
Oh, you don't have to write the instructions. That's okay. Examples. Go ahead and just write 3 and 4. You don't have to write the directions if you don't want to. But I want you guys, as you're writing and as you're reading, you have to read to write. You have to write what you're reading. I want you to think of, is it growth or is it decay? Is it growth or is it decay? Oh, thanks for helping out. Oh, yes, please. I appreciate that. I want you to think of growth or decay. Okay, so Diego thinks. Diego, how did you know that number 3 was growth? I totally agree. How did you know? Good. So as soon as you read or hopefully you wrote the word increase, hopefully you thought of growth. Now number 4, what do you guys think it is? Which means?
Or decay, sorry.
Okay. So we're going to have to use a growth equation for number 3. We're going to have to use a decay equation for number 4. Those equations that we just reviewed. Now, can I go back here for a second? Number 3, growth. We have to fill in A and R. True? Okay, so what do we have for A and number 3, guys?
35,000.
Good. We can go ahead and just use that 35,000. Jordan, you okay, kid?
Yeah.
Okay. We can use that 35,000 as our A. Now we need our 1 plus. Question, who are we adding? By what percent is it?
0.04.
0.04. Make sure that you're thinking of moving it over 2 decimal places, right?
0.05.
And then what do we have to make sure to put into our exponent to make sure that we have our exponential function? What variable goes up there? T. Does that make sense? So we have our A, we have our R, and we have our variable. Are we done?
No.
Of course. Actually, yes, we are. Because look, all we had to do was write an exponential function. Sure. Done. Now, in number 4, since it could be 12. But we have to make sure we have these formulas down, right?
Yeah.
In number 4, decay. We're still going to start the exact same way, right? Hey, what's our A? That's a lot of rhyming going on. What's our A? Okay, it's our initial amount, which is 900. Since it's decay, what are we going to put in our parentheses? 1 minus. By what percent is it? Careful.
Zero, sorry.
Yeah, 0.09. We have to move it over 2 decimal places. 9% is 0.09. And then what do we have to make sure to finish off with? Our T. How'd it go? We got it?
I didn't know whether it's a 1 plus or 1 minus.
Exactly. Good question. Who wants to try to explain that to
I
me?
do.
Josh.
If it's under 1, then it's wait.
But you have to.
Close. Hold
Actually,
on.
no, never mind.
Just because you were outside, let's move it off to Jay. Jay, go ahead.
If it has increases, like if it increases, then it's plus, so it's
Because it's
Oh,
growth.
try
Oh,
it.
I
it's
see.
a growth, and then if it's subtracting, it's
Decreasing, going down, that'll be your decay, so then minus. Does that make sense?
So that it doesn't matter if it's less than.
And these ones we were making it ourselves, so we didn't know until we made it. Does that make sense?
Okay, so let's just say you have 1.1 and 0.94. And the top-
1.1 would be what kind of equation?
Yeah, but what if it says like decreases?
It's never going to say both because it would contradict each other. So it would be like an impossible problem.
Oh, okay.
Does that make sense?
I was just making sure.
Now, actually, what Josh was asking just a second ago, that's exactly what I want you guys to practice one more time here. We practiced it in our homework questions. We did it with our equations. So Aiden and Jordan, make sure you're focused on us. I want you guys to do these 2 examples. Read the directions. You don't have to write them. But it says determine whether the function represents exponential growth or exponential decay. I would write the examples down because it needs you to label it as growth or decay, and then find R. It's not making you do find A or plug in 3. All it wants is for you to figure out, is it growth or is it decay, and what is R?
I think T. Would you plug in T right there? No, you wouldn't, right?
Nope, you wouldn't need to plug in T in this one because they're just asking for, is it growth
No,
or
I'm
is it
saying,
decay?
like, you know how like it give you T,
Oh, that's
like
Oh,
T equals
sometimes.
3, you plug in T right there.
Yeah.
Or F.
If they were asking. It's a special thing called function notation. Oh. Function notation F of X. Okay, a couple more seconds. I want you guys to literally write growth or decay underneath each one. You gotta pick one. And then I want you to see, can you find R by yourself? Go ahead. Can you find R from what we've done today?
Yes.
Okay, then try it out and we'll check the answers.
Alright.
Alright, what do you guys think for number 1? Growth or decay?
good.
Growth.
Uh-oh, I heard this one first and I'm gonna keep it.
Yeah.
Oh, why is it decay?
Because.
Good.
What's less than 1?
Oh.
You see it?
Oh shoot! I meant to write decay on.
Oh, okay, never mind. That's okay, that's okay. Let's fix it for number 2.
I had it
Can
right,
we all
though.
get number 2 right? What is it?
Right.
How come?
Because it's
Oh, yeah.
over
One.
Good, because it's over 1. Now let's figure out, I'm not going to set up the whole equation because we did that earlier in our homework questions. But can you guys help out?
8%.
How did you get 8%? I totally agree, Aiden. Rob, oh, go ahead, Aiden, you want to explain it?
Alright.
No, go ahead.
You subtract 92 from 1, and then you get 8% because you move over the decimal twice.
Yeah, and if you guys aren't liking the decimals, couldn't you also think of 1 as 100%, right? And couldn't you think of 9.92 as what percent?
92.
So you could just think of, hey,
Oh.
subtract from 100%.
That's kind of true.
Does that make it a little bit easier? 100 minus 92 is 8. Rob, do you have a question, bud?
Yeah, so
Yeah.
even if it's less than 1 or more than 1, it determines whether it's going to be growth or decay.
Exactly. Does that make sense?
Yeah.
So then over here, guys, can't we think of 1.2 as, wait, hold on, 1.2. That did 120%, right? Struggle, I know, I'm using the mouse today, my iPad's not working.
It's okay. Better than that.
What am I gonna subtract?
Well,
1, which is the same thing as 100%.
Oh, so it would be 20.
20%.
Yeah. So this one, now how would we say it? Here's a little bit of a struggle. Okay, it's okay, focus on on number 1, we would say it's decreasing by 8%. On number 2, we would say it's increasing by 20%. Does that make sense, the difference? Growth is increasing, whereas decay is decreasing. Now it's going to get a little bit harder, but can you guys just write these couple of things in your notes?
Yep.
We have 2 more quick notes in the sense of this page, and then we have some more examples, and then we're done. It's really close.
Opa.
But we do have some tricky examples at the end, so let's get it down. Big idea. Exponential growth, your base is above 1. You can subtract 1 to figure out what R is, the percent of growth. For decay, the base is under or below 1, so you can subtract once again the 1 to figure out the rate of decay. And that's what we just saw in those examples that we did. Dylan, you get these notes okay, then? Alright, hang in there. I know, it's enough. So let's write down these notes word for word, and then I want you guys to look at those tables below. And once again, I want you to ask yourself which one shows growth and which one shows decay. So get these notes down, word for word. I would write the table. Because that way you can recognize it, because you have to do some tables and homework. You don't have to make them, but you do have to recognize the pattern.
You don't have to make 2.
They actually give you tables, and you have to identify growth.
So we should write it.
So in your notes, let's write it so we're ready. Yeah. Hey, do you guys still see the multiply? Nope. The add, multiply pattern?
Yeah.
Right? Okay, good. So exponential, we still have add, multiply, but there is a difference.
Oh, yeah.
I want to go eat.
Somewhere you guys left stuff in the car.
Can't go with more than that. Can't get too much.
Alright, kiddos, looking at these tables, my question is, which one shows growth and which one shows decay? What do you guys think, just logically looking at it? A is decay? Rob, why don't you explain why?
Because, okay, decay is under 1. So down 1 is under 1.
Yeah, do you guys see, well, as you go up 1, what happens to your y's?
It goes,
The amounts go down, good.
Increases.
And do you see why? What were you multiplying by?
1/3.
Yeah, if you take a third, are you getting more or less?
Is 0.3.
Yeah, 0.333 or 3 repeating.
And on B, you're getting 2.
And then on B, the y's are doubling, so times 2 is going to be growth. Now, both of them show, focus on in. On A and B, both of them have, Josh, it's okay, both of them have the add multiply pattern, right? But on A, you're multiplying by a fraction lower than 1, and by B, you're multiplying by a number bigger than 1. True, true? Yes. So A, does that still make sense? Growth,
Yes.
multiplying by something bigger than 1. Decay, multiplying by something less than 1, yeah? So let's go ahead and look at the last thing we need to do. Ugh, this is where it gets tricky, guys. Here we go. I need all the brain power you guys can give me.
12%.
What do we do when it says rewrite the function? What do we do when we have an exponent other than t? Yeah, kinda. So Josh, focus, this gets rough. What do we do when we need to figure out growth or decay and there's not just a t? Do you guys see how it's different? Sometimes. Sometimes divide, but all we set up above, all I set up above was rewrite. Now, how do we rewrite exponents? Using the rules. Backwards. Now, hang in there. Hang in there. When you raise a power to a power, do you guys remember the rule?
No.
When you raise a power to a power, you multiply. When you raise a power to a power, you multiply. So question, is this rewritten form doesn't mean the exact same thing? Now, who has a scientific calculator? Get it out. Someone who knows how to use their exponent button.
Oh, you did that.
Or a scientific calculator. Either one. Who knows how to use their exponent button? I want someone to try to find for me 1.02 raised to the 10th power.
I got you. 210%.
It's 210 to the 10th power.
Oh, swear.
But meanwhile, guys, we have something else to rewrite over here. So as someone's hopefully helping me out. Question. Do you guys remember what makes powers add? Oh, I have to stay another minute. Stay another minute. That's quiet. I'm done. What makes exponents add? You guys remember? Like bases being multiplied ends up adding the exponents. Now hold on, check it. You're gonna have to do this in homework. Do you remember the rule that says if you have like bases, you add the exponents? If you have like bases, you add the exponents? Yeah. So we can go backwards and say, uh-oh, you know what? This isn't the proper form. We have to somehow undo this. And so we have to go backwards in the rule, even though we're used to going forwards in the rule. Same thing here. We have to go backwards in the rule. Nope. You have another minute, remember? Go backwards in the rule, even though you're used to going forwards in the rule. Now, who's found for me 1.02 raised to the 10th power?
No, wait. Is it the same?
No, we gotta raise it to the 10th. Alright, who has a calculator for me? Because you guys are supposed to have calculators.
My sister took my
Why did you?
They were gonna do 10
My retarded fish shaped my calculator.
Because we need to split up the 10 and the t, they don't belong together. Exponential growth says just a t. And over here, we have to do t plus 2, but that's not proper either.
What is it?
Okay, I need 1.02 to
To the fifth one.
the 10th power. What do you got?
1.218994419.
Okay, let's just get some of the decimals. So we'll do 219. Question, kiddos, look at this equation now. Is it growth or is it decay? Good, but we had to figure out what this number really was on the inside. Now, Jay, I need you to do one more thing. Can you do 0.95 squared? He's getting his calculator out. What's 0.95 squared? We had to rewrite them by splitting up the powers.
0.9025.
Which one? 0.9025.
So you already got it? Okay, good.
Yeah, I already got it. Now, kiddos, now it's written in the proper form. My question is it growth or is it decay? Decay. But we're going to have to rewrite using our exponent rules backwards to get it in the proper form. So were they in the proper forms to begin with, everybody? Yes or no? No! What rules do we have to use to rewrite each of them? The exponent rules from section 6162. Guys, work on this homework tonight. We put it up one more time in case you didn't get it. You need a picture on the back door. I'll see you tomorrow. Bring your calculators tomorrow. We need to review.
I think it'll be over here.
Mama!